Alright, so what we're going to have here is a triangle, and I'm going to start with a nice little right triangle. There we go. Alright, so we're going to build the formula for the area of a triangle off of the area of a rectangle, because if you look at this triangle here, it can be understood or seen as half a rectangle. So if I just highlight in the other half of the rectangle, basically we've chopped that part off and thrown it away, and that's how we get triangles. If you think about you want to cut a perfect right triangle out of a piece of paper, what you're going to do is just cut a rectangle in half. It does get more complicated if you have a triangle like an obtuse triangle. The rectangle isn't as obvious, but again, if I highlight in, like if I try to just square all this out, do it with two different colors, then what we have there is that the yellow part is half of that yellow part, the blue part is half of the other blue part, but together, that all together makes one big rectangle. So even those can be seen as half of a rectangle. So that's the idea of how the area of a triangle works. So if I go back to what I did, if I'm looking at this entire rectangle here, the entire rectangle here. So when we looked at the rectangle, we said that this was our length. And some people might want to call that width. It doesn't matter because I can face it differently on the page. And this is our width. And then our formula for the rectangle was equal to that length times the width. Okay? Well, so then the area of the triangle would be half that, or 1/2 the length times width. Now here's where it gets a little wonky, because when we deal with triangles we don't like to talk about them in terms of length and width, and I'll explain why. But essentially, instead of using those words, we use base and height. So when you see the area of a triangle expressed, the formula for the area of a triangle expressed, it's usually expressed as 1/2 base times height, like that, which is the same as the length and width. It's just when we're dealing with a triangle, we want to call it a base and a height. In this case, it doesn't necessarily seem, it's not obvious why that's necessary. So we'll look at a different triangle to see why that's necessary. I'll go back to the other one that I had drawn before. So if I have a triangle like this that is a little obtuse and it's not clear, if you're talking in terms of length and width, it's not clear what that means. And so that's why we switch to base and height, where the base is going to be one side of the triangle, and it can honestly be any side of the triangle. So I'll make it this here, and then the height is going to be the distance from that base to the opposite point. So the height does not go along the diagonal, which is one of the reasons why we're getting away from width and length, because we're not going along the length of the side. That is not what we're doing. It's going to be the distance from the base to the height, to the opposite peak there, measured in a perpendicular fashion. So that's your height. Sometimes you'll see that people talk about dropping a perpendicular. So you'll see it going down the triangle like that. We'll put a little square out there, and that emphasizes what's needed with the height. And that's the idea that the height is perpendicular. It's a length that's perpendicular to the base, from the base to the opposite vertex of the triangle. So again, the height must be the perpendicular, that's an important word, distance from the base to the opposite vertex. And by perpendicular we mean that it has to make a right angle or 90-degree angle with the base. Let's look at a different configuration so you can see how this would look differently. It was straightforward with this right triangle over here because you have two sides that are right angles of each other. But when you don't have that in a triangle, you have to draw the height in yourself or identify the height yourself. Okay, now let's say I have this triangle and I just want to make the bottom that's drawn on the bottom my base, or B. Then my height is going to be the distance from this edge to the opposite corner. So the opposite vertex is always going to be the one that the base isn't touching in a perpendicular fashion. So I have to draw my height perpendicular or straight up from the base. And however far that takes for me to get, that's going to be my height measurement. That wasn't drawn very well. That was particularly poor. Okay, so that's one way to think about it. The way you'll see it drawn in figures a lot is they actually come out this way and like this. That's going to be the same length regardless, but that's how you get your height, is going perpendicular to the base. Now, what I think is interesting with this figure is oftentimes they'll draw these on a page to like see if a student will get the height correct by going out and then up instead of just measuring along the length, which is never what you want to do. But if you compare this figure to this figure, they're essentially the same. They're both obtuse triangles. It's just one has put one of the shorter sides down at the bottom, and there's this compulsion to want to make the bottom the base, the lowest point on the triangle. But this triangle doesn't actually exist on this page, and so you can make any side a base. So I can make this side here my base. Oops, doing so killed off one side of the triangle. Alright, so I make that side my base, and then my height could be like this. As long as it's perpendicular to that base, that could be my height. Right there. Maybe I'm going to draw the H upside down. Well, that might be a bit confusing. But it's not to me because I like to flip things around in my brain. But anyways, so that could be our height. So the base doesn't have to be the bottom of the triangle as it's positioned on the page. So you want to choose your base based on what you can figure out. And it sometimes is easier to make your base something that's not at the bottom, so to speak. So you just want to choose your base strategically so you can actually figure out your base and height without too much effort. And sometimes it's all the same. Sometimes there's strategic reasons for choosing a particular base, and that's just something you need to strategize as you work it out. So all of that is to explain why we call stuff base and height and what the height means. It's not it's never the distance along, well, if it's a right triangle, it is the distance along the edge, but normally it's not measuring the distance along the edge of a triangle, it's measuring the perpendicular height from the base to the opposite vertex. So now that we have that down, let's actually do an example of finding the area of a triangle. Alright, let's say we have this triangle here where we have our base is 3 inches, and our height is 2 inches. I do want to caution you that as we learn more things that we can do with these geometric figures, you won't always be told the base and the height just outright like this. This is a really kind problem. You will get to ones where you have to figure out what the base and height is. And so just be forewarned. But the area is going to be half the base times the height. And if you take the time to write the formula there and say it in your head as you write it, that'll help you remember these formulas. So the area is going to be 1/2 times 3 inches times 2 inches. Okay, and you could do this math in any order you want. You can take 1/2 times 3 and then times 2, or you can take 1/2 times 2, which is 1, and then times it by 3. Regardless, this is going to be 1. So what I'm doing here is I'm going to take 1/2 times 2, and that's 1. And then you get the 3, and then you have your 2 inches multiplied. I'm not implying you need to show the work like this. I'm just trying to show you how I kind of reassociate the half. So if I have an even number, I just slash it in 2 is what happens. So it's 3 inches squared, or 3 square inches is the idea. So that's how many tiles, 3 square inch tiles it would take to tile that triangle. Now in reality you would have to cut some of them in halves and what, but the total area, or along the slant, but the total area would be 3 square inches. Alright, now that we have triangles in the bank, let's look at parallelograms.